So this was our setup. Here's our labor market. Here's our production function. At the intersection of labor supply and labor demand, we have equilibrium in the labor market. Equilibrium in the labor market corresponds to what we call full employment. With some full employment level of labor employed, we produce some level of output called potential output. What we saw was that an increase in labor supply. What sort of things could generate an increase in labor supply? Well, as your population grows, you'd expect your labor supply to increase, right? If there's a change in some regulation, maybe retirement age is increased, so instead of retiring at 64 or 65, companies instead allow people to continue working until 70, 75, right? Those are going to shift our labor supply out. So if our labor supply shifts from LS0 to LS1, our level of employment increases, our level of full employment increases, which leads to a movement along our production function, which corresponds to a high level of potential output. What the notes don't have, and what the textbook does have, is a discussion on the alternative way of increasing output. Increasing employment and therefore increasing output. And that second way is obviously to shift labor demand. Labor demand here being a function of the real wage. So if labor demand is a function of the real wage, what we're saying is that the amount that we need to pay people matters for the amount that we want to employ them. Okay? And the amount that we're going to have to pay them must be compared to the amount that they bring us. Okay? So when we employ someone, they generate revenue for us, right? So what it's saying is, as the real wage goes down, so the amount of revenue that each person brings in relative to the real wage increases, right? In other words, as I employ more and more people, as they generate more and more output, I generate more and more sales, they generate revenue. If the extra revenue that people are bringing in is greater than the real wage, then I'm happy to employ people, right? As soon as the real wage is greater than the extra revenue someone's bringing in, then I don't want to employ them. Why would I do that? They're bringing in 100 Rand revenue, I'm paying them 150 Rand in wages. Am I winning? I'm going backwards, right? But what happens if there is a technology advance? My company becomes more productive, so that instead of only bringing in 100 Rand, each person now brings in 180 Rand. So when people were bringing in 100 Rand, when the marginal contribution of the next employee was 100 Rand, the marginal revenue, and the wage was 150 Rand, I wasn't prepared to pay 150 Rand to get an extra 100 Rand. But if there's a technological advancement, and now my laborers become more productive, and the marginal revenue that someone brings in is 180 Rand, am I prepared to pay someone 150 Rand to get 180 Rand extra revenue? That would make sense. So if there's some kind of advancement that makes my laborers more productive, my labor demand curve shifts to the right. In other words, at any given real wage level, I'm prepared to employ more people. Or alternatively, for any level of employment, I'm prepared to pay now a higher real wage, right? Because my laborers are more productive. So if this was our initial equilibrium point here, call it point A, and point A corresponds to point A up here. When we shifted labor supply, we got to point B, which corresponds to point B over here. What happens when we shift labor demand? So labor demand goes from LD0 to LD1. Are you happy that we employ more people in equilibrium? Right? So if we were to take this level of employment and just run it up here, more people would be employed at point C compared to point A, right? But remember, these people are also more productive than they were before, right? Their productivity has increased. That's why my labor demand has increased. Which means that if I compare, excuse me, the amount of output that this quantity of labor was able to produce previously, this is what they would have been able to produce previously. But because they are now more productive, they are in fact able to produce more. In other words, my entire production function curve has increased. Are you happy with that idea? So you see, when we shift our labor demand curve, not only do we have an increase in employment, we actually have an upward shift in our production function. In other words, we don't just have a movement along a production function, we actually have a shift in the production function and an increase in employment. Questions? And then the textbook just sort of details why we would expect the labor supply curve and why we would expect the labor demand curve to move, and talk about that in slightly more detail. There's a lot of discussion in the textbook about basically saying all of this depends on labor's incentives, okay? But apart from labor's incentives, we also have what we are assuming basically in this diagram: some level of labor, and some level of capital, and I'm going to put a bar over it because that means capital is fixed. Okay? So what I'm saying mathematically is output is a function of labor and capital. Okay? In these diagrams here, all we have spoken about is labor. In other words, for now, capital is fixed. Capital is some constant, K bar. What happens when we no longer fix capital? Something else happens. Well, in the same way that our labor productivity, right? We said technology could increase labor productivity. So capital can increase labor productivity. Okay? As we get more computers into our firm, our labor has become more productive. More robotic stuff comes into the firm, our labor has become more productive. That's a capital change. We upgrade the software that those robots are using so that everything works better. That's a technology change, right? So labor demand can shift, we said, either because technology changes, or what I'm now saying is also this shift in labor demand can also be driven by, for example, LD0, labor demand 0, was for some level of capital K0. If K increases, so we started at capital 0, and now we've got some level of capital K1 that's greater than K0, so our capital is increased, our labor demand can shift. In other words, that's labor demand at K1. So what happens when we change capital to our production function? It would shift upwards. You happy with that idea? Why? Because this is a productivity issue. Okay. How productive are our laborers? If we change their productivity, we shift labor demand. Changing productivity shifts production function. Okay? If we change anything that affects labor supply, then we've got a movement along a production function. When we shift labor supply, we are not changing labor productivity. Labor productivity is a change in labor demand. Okay? So if we have capital growth, capital grows from K0 to K1, what do we end up with? Our full employment level of output, you can see, has gone from A to point C. In other words, our laborers are more productive and we employ more people. Another kind of productivity that we spoke about, I mentioned technology, right? Another kind of a technology is, for example, what we call human capital, right? So if you guys improve your education and you go into the workforce with a higher level of education, in theory, you are more productive, right? That's the idea. Why are you going to get paid a higher wage? Because you are more productive. The demand for your labor, right, gives you a higher wage because you are more productive. You are able to generate higher revenue for your employer. You get a higher real wage. So if your workforce becomes more educated, excuse me, so your human capital goes up, production function shifts as well. So 3 changes. You can either have a change in technology, change in capital, or change in human capital. My apologies for the brief interlude. I'm going to leave this over here just in case we need it. We're going to talk about this. We'll see if it flickers. He's just going to go and see if he can find another cable. The problem is potentially in the connection to the computer. Right. So this is the slide that we were on. We basically just finished it. Change in physical capital. So here we got physical capital, human capital, technology. And basically, depending on how influential you think those different aspects are, kind of determines which growth theory you're going to lean towards. So we're going to talk about a couple of different growth theories, and they kind of are chronological. So we start with classical growth theory, then we move to neoclassical growth theory, and then after the problem with neoclassical growth theory, new growth theory. So those are our 3 growth theories that we're going to look at, and they come chronologically in time. They follow the way we're going to discuss them. So what happens in classical growth theory works like this. In fact, I have something that would be really potentially quite fun to show you. I just got to figure out exactly where I've put it and what it's called. Okay, Netlogo, there we go. So Netlogo is a programming language, and now maybe I'm a little bit out of my depth here, but did any of you ever, when you were young, and this is where I think maybe I was young, very differently to the way you were young, but did you ever play or encounter at school ever something called Logo? It was like a little turtle, except it wasn't a turtle, it was a triangle, but they called it a turtle. And you inputted computer code to make the turtle move. So you could say forward 10 and the turtle would move in the screen. You guys never did that? No? Yeah, I did that when I was in, what's class 2? Whatever. Grade 2, we did that for some reason. Different education system. Anyway, so that was Logo. This is something called Netlogo, which is basically take that programming language and like make it 1,000,000 times more exciting. And basically, you're just moving little turtles around. And because you're moving turtles around, it works. It works in something called agents within a space. So your turtles are agents, and they move in a space. So here's a model called the predator-prey model, and hopefully it will show. I'm just going to... Can you guys see sheep and wolves? Let's turn this down. Okay. Can you see these little sheep? The white things, and the little wolves are the red things. Okay? Oh, and I'm also going to turn the grass on. Hang on. Okay. Oh, okay. The orange bit is grass, which is supposed to be green, and then that dark brown bit is sand, right? So the grass, the sheep eat the grass, and then once they've eaten the grass, it needs to grow back. So you can't eat the same. Once the grass is gone, it's gone, and then you leave it for a while, and then the grass grows back, right? And then the wolf eat the sheep. Now, what we're going to look at in this graph over here, you can see, so it's blue. The blue line is going to be the number of sheep. The brown there is going to be the amount of grass, and the orange is going to be the number of wolves. Now what we do is we just let these little guys run around and find each other and hunt each other. And you can see the populations are, okay, it's moving quite slowly. Just hang on, let me just speed it up a bit. Sorry? They have like a reproductive process, and the wolves also have a reproductive process. Yeah, you need to talk to your mom and dad about that. So the more grass the sheep get to eat, the more successful they are, right? The more food the sheep get, the more energy they get, the more reproductively successful they're going to be. The same with the wolves. The more sheep the wolves get to eat, the more energy they have, the more reproductively successful they are, right? So I've just speeded it up a little bit. Let's just see that this, there we go. So you can see as the, let's do this now for a second. I'm going to turn the grass off and set it up again. Notice, oh, oops, okay, that didn't work. Okay, let's just stop it there. Are you happy that as the sheep population increases, it becomes more and more likely for the wolves to catch a sheep? And then as soon as there's lots and lots of sheep, the wolves just start getting out of control, right? And then once there's too many wolves, they actually start reducing the sheep population, which then has an effect on the wolf population. This is ecological dynamics, okay? And if all the wolves die, well then the sheep just become a pest, right? Now the wolves don't always die, although at this point in time they are continuously dying. If we put a limit to the amount of sheep, right, or the energy that the sheep can get, and just give us a second, then you can see that the system is a little bit more sustainable. And you can see the ups and downs go together, but you kind of get an equilibrium in that system, right? So this is called agent-based modeling, which is quite fun.
I'm going to unplug.
Yeah, go for it. So what